we know that there is plenty of right building blocks out there in interstellar clouds. And there is water, there are other solvents like methane, there are many different organic molecules, including very complex ones, all the way up to the amino acids. And so that material is then used to make planets in protoplanetary disks. So there is plenty of right chemistry. Now what happens is once you have a planet with liquid water, it's what's called a primordial soup. And it was a famous experiment by a guy named Miller, where they combine the type of compounds they expect to see in proto-Earth's oceans and put some electric sparks to mimic the electric discharge and everything else. And lo and behold, out of relatively simple mix of compounds, they started creating very complex organic molecules. So if you can do this in a lab, certainly planet-sized lab, waiting for a couple of billion years, you can do it even better. So it's very natural to expect that you will be forming at least basic material for life if you're in a habitable zone, there is liquid water, everything else is kind of provided. So there is now a whole field of astrobiology which is dedicated to learn about life in the universe and where it's possible, how is it possible, and so on. And they concern themselves with extreme environments on planet Earth that can be used as proxy for some of the harder environments out there. And so, for example, there deep at the bottom of the ocean, there are these vents called smokers, which are of volcanic origin. There's a lot of sulfur compounds. There is no light down there. It's so deep. And there are bacteria. Now, those bacteria actually use sulfur instead of oxygen for their metabolism because it's not quite as efficient as an oxidizing agent, but it can be still used. So this is a very different kind of, I mean, it's obviously related to terrestrial life on our planet, but functions in a very different way. Likewise, bacteria have been found in hot volcanic lakes. They're just saturated with all kinds of minerals, including arsenic, and they thrive. So the life in planet Earth can adapt to some extremely harsh environments. There are even bacteria found inside rocks, right, that have been dormant for a long time. And the bottom set of pictures is actual microphotographs of microorganisms found in Lake Vostok, which is a lake on Antarctica under a few kilometers of ice. So that lake was enclosed by the Antarctic ice many millions of years ago, and in some sense, it could be a model of what life on Europa or Enceladus could be. So sure enough, they found there are microorganisms. I think all fish died a long time ago, but there are these, and they don't have any light down there, so presumably they'll be getting their energy from somewhere else, and they're not yet classified. So we know that that's possible too. So what about life in the solar system? Mars is everybody's favorite, and this is artist impression based on the actual topographic map of Mars, that once upon a time, Mars had an ocean. There is now plenty of evidence for that, from surface features, etc. And it could have looked like this. This was like 4 billion years ago. And in that case, Mars probably did develop some kind of life. So one of the major goals of Mars missions is to actually look for signatures of that chemically or even fossilized bacteria or things like that. But for my money, the best place to go would be moons of Jupiter and Saturn, because some of them have oceans under the ice, Europa and Enceladus for sure, probably some others. Others have enough geotectonic activity, like Io has volcanoes with sulfur, plenty of energy. And Jupiter has radiation belts, and that radiation actually can serve positive purpose of mutating molecules or protocellular life, and the hardiest ones to survive. So I would say that by far most likely place to discover some sort of life in solar system would be one of those large moons of Jupiter or Saturn. Maybe more of them, we'll see. But what about beyond our solar system? Well, that of course has been territory of science fiction forever, and people have been trying to find extraterrestrial civilizations. SETI is the acronym commonly used, And it's based on what I find highly questionable assumption that advanced civilizations would choose to communicate by the middle 20th century planet Earth technology. Could just as well choose smoke signals. So what would they use? Well, we don't have any idea because they're more advanced, right? But nevertheless, if they did indulge in such an eccentric thing, you could look for modulated signals, and you have to search so-called cosmic haystack space of area in the sky, flux and frequency and modulation, and a very successful, in terms of actually amount of data processed, nobody's found anything, is this project SETI at home that crowdsource computing. They just piggyback on radio signals that are collected in Arecibo and VLA and elsewhere for completely different purposes. And they shove it through a program that will look for particular modulated signals. They recover all of solar system probes, so we know it kind of works, but that's the artifacts that we created. Another possibility is search for extraterrestrial artifacts. Have advanced civilizations visited us previously and left something for us? And it could be a black monolith, could be something buried on the moon, could be something found in Earth's orbit. And so just to return the favor, we sent them a few postcards on interstellar probes, Pioneers and Voyagers, that have left or are about to leave solar system. Carl Sagan designed this, and somebody called this pornography in space. So how many do you expect to see? And Frank Drake is a pioneer of this business, started in the early 60s, came up with the following simple equation called the Drake equation, which is a product of a whole bunch of probabilities. How many civilizations are there in our galaxy that we can communicate with by radio? Well, first, how many stars they make, how many of them have planets, how many are suitable planets, how many develop life, how many develop civilization, how many survive long enough to actually communicate with us. And so some of these numbers are much better known than others at this point. Anything to do with astrophysics, like star formation rate, the numbers of planets, and even how many might be in habitable zones, we can now have pretty good estimates of those. How many actually develop life? Nobody knows. What fraction develop intelligent life? Even less people know. And in fact, you could ask whether there is intelligent life on planet Earth, but that's not good. And then finally, how many of these advanced civilizations will bother to actually do this kind of Morse code type of communication? Well, so as usual, XKCD has one of the best comments on this, which is how many people claim to have seen UFOs. I'll let you read this on your own in PDF of the slides online. So one last thing is this thing called the Fermi paradox, which is due to Enrico Fermi. During some lunch conversation, he came up with this question, where are they? And the point is that, well, even if you travel at a measly speed of 1% of the speed of light, which is not too crazy to imagine for advanced civilization, it will still take you 10 million years or so to cross the entire galaxy. And you can do this robotically or with actual aliens in space starships and so on. And so if there is a star-faring civilization, they could populate or explore galaxy in 10, 20 million years. And the galaxy is 12 billion years old. So I think there's plenty of time. So if there's a single one of them, they should be around here. And so the question is, why don't we see them? Right? Well, some people think that we do. And there's been actual books about this. There are over 100 different proposed solutions to the Fermi paradox. Why we don't see obvious manifestations of extraterrestrial civilizations, because they had plenty of time to make themselves known.